Greetings everyone. Well, welcome to our channel, College Course Solutions Mathematics, and let's get started. So today we are gonna be looking at logic circuits or networks. So what they basically mean by logic circuits and networks is that they are the questions that you are given through the symbols of the logic gates, and you just have to go each and every step in order to reach to a point where you have acquired the output X. So I will be taking you through each and every step. As you can see, for the question that we have chosen, we actually have 3 steps, which is mainly to tackle for the first step, which we will be using taking input A and B both through the NOR gate, and so in the beginning we didn't have F and G. I have just named them after understanding of the outputs in which we get after tackling for through the AND gate and the NOR gate. So we're gonna start with the of course in the question there are 3 inputs, which just means we have the possible combinations of zeros and ones. So what you want to note is that for input A, we actually, where we have input 3 inputs, where there are 3 inputs, we just put them as 2 is to power 3, meaning there will be 8 possible combinations of zeros and ones. So what that simply means is that for A, we start with 0 0 0 0, which are 4 zeros which are following one another, and then we go to 1 1 1 1. Now when it comes to B, we have 2 zeros and then 2 ones, which will be 0 0 1 1, and then again 2 zeros and 2 ones. Now for C, we have just 1 0 and a 1, a 0 and a 1, and then a 0 and a 1, and a 0 and a 1. That's how we have the 3 inputs. We like them like this. So if there were 2 inputs, we will leave it at that. Even if the 2 inputs were represented by letter A and C, we would not write C like this, because it will just be another input. We will write it like this at the position of B. So so for input A and B, so for the first step, we are going to be using input A and B in order to acquire F, which means we are going to be using the NOR gate. And of course, if you don't know how which statement the NOR gate actually follows and its explanation in order to acquire the results, I would greatly recommend another video where we have tackled the logic gates. The link will be in the description, but just for calculation purposes, I have chosen to actually write the statement here. But in order to understand further, I would greatly recommend you watch that video on logic gates. So for input A and B, going through the NOR gate, the NOR gate actually basically just states that output X is true. In this situation, output X for us would be F if input A null B are not both true. So in this situation, we have input A and B where they are not both true, so we will have output F as 1. And in this other situation, they are not both true, then we will have the output F as 1. Here we have B as 2, which means the output F will be 0, which means not true. And here of course we have 1 which is true, giving us output as not true, and the others we also have values of true. Remember, the statement states clearly here that we can only have output X as true where both of them are not both true, which means in only the situation where both of them, input A and B, are zeros, and we only have 2 situations like that, where we have zeros and zeros, where we have gotten output F as 1 and the rest will be zeros, since we don't have any other situation where A and B are both not true. That's how we find F. F will be 1 1 0 0 0 0 0 0. And then of course that's the first step we are going to use to get the output F. And now for the second step, you're gonna note we have two combinations, which is B and C, and they have taken the, you can see the line is drawn before B is actually goes through the NOR gate, which means we just take B as the way it is, and C, and we are gonna be taking them through the AND gate in order to acquire the output G. As I have said, I have just named them just respectively and randomly, which means you could name them with other letters we are choosing, so that your work may not confuse you. So for in order to acquire output G, we will be taking B and C through the AND gate in order to acquire the G. So, and just for your understanding, I have stated here the AND gate actually state output X is true if input A and B are both true, which means it's only in a situation where A and B are both ones, where we are gonna have output X as ones. As I have said, if you don't understand, please kindly watch the logic gates video. The link will be in the description. It will help you understand more clearly on what we mean when we say output X can only be true if only A and B are both ones. So in this situation, A and B will be B and C, since they are our two outputs. So here they are both false, so we'll have the G as false. So here, of course, the one is true, which means we will have. So sorry, there was a mistake here in the typing. Since B here is false, it means then this output can only be false, because the output can only be true in a situation where the outputs are both true. Also here will be false, and here we have input B as true and input C is also true, which means we are going to have this one as true. And then in this situation we have 0, which means input B is not true and input C is actually also not true, so we have output as not true. So on here then we're gonna have the input B not being true and input C not being true, which means here also we're gonna have output not being true, and also here input B is gonna be true and input C is gonna also be false, which means here we are gonna have the output as false. So that's gonna be our G. It will be 0 0 0 1 and 0 0 0 1. So so then in order to acquire the output X, it means we have to pass the F and G through the OR gate. So what we just basically do is that we're gonna pick this F and G combinations, and be correcting any other mistake that may have been resulted to the mistake we had made earlier before on G. And on OR gate, it actually just states output X is true if input A or B is true. So it means if either one of them is true, then the output becomes true. So in this situation, since we are taking F and G through the OR gate, so in this situation F is true, so it becomes true. In this situation F is also true, so it gives an output true, since we only get the output as true when either one of them is true. In this situation either one of them is true, so here we just have output as not true. So here neither of them, one of them is true, which is G, which gives us a true output. So on this situation neither is true also, so we get an output that's not true, on here neither is true, so we just get an output that's not true. And here of course neither of them is true, so we just get an output that's not true. Here we have this as true, so we just get an output that's true. So that's gonna be our output X. I hope you followed each and every step, since if you have understood, you can be able to tackle any questions that's actually brought on logic circuits or network. And also you should note that to take these questions seriously, since I have not come across a question that has less than 8 marks. I also recommend that you do more practice so that you may understand. Thank you. I hope you understood, and also kindly don't forget to subscribe and hit the bell icon. Thank you.